During my PhD, I worked on a species of bird called the chestnut-crowned babbler, which lives in the Australian outback. Babblers live in groups all year round, collectively mobbing predators and engaging in territorial interactions with other groups. When they breed, only one female lays eggs, with the rest of the group acting as helpers, bringing food to her chicks and defending the nest. Babblers are an example of a cooperative breeder, a species in which non-parents also provide care for offspring. The question is, why would other group members help someone else to breed when they could be breeding themselves? Why does natural selection allow helping behavior to stick around? The explanation for how cooperation might persist differs depending on whether you're talking about cooperation between relatives or between non-relatives. In this video, we'll explore what we mean by cooperation and discuss why relatives might cooperate. Whenever animals live together, there are many ways individuals can benefit from the presence of others. So we first need to define exactly what we mean by cooperation. There are two criteria that must be met for a behavior to be truly cooperative. Firstly, it must provide a benefit to another individual, usually referred to as the recipient. Secondly, the behavior must have been selected because of this beneficial effect on the recipient. This second point is needed to exclude cases in which individuals benefit from each other purely as a byproduct. For example, small birds often forage near larger animals, collecting insects as the larger animal disturbs the foliage or substrate. The larger animal's behavior clearly benefits the birds, but this isn't cooperation, because its behavior would be the same if no birds were present. With this definition in mind, there are two fundamental types of cooperative behavior: mutual benefit and altruism. Mutual benefit occurs when a behavior benefits both the recipient and the actor, while altruism occurs when the recipient benefits but the actor suffers costs. As usual, when we say benefit and cost, we're thinking in terms of evolutionary fitness, meaning things like the number of offspring or likelihood of surviving to breed the following year. It should be obvious that natural selection will favor mutual benefits directly. We don't need any special explanations for why animals cooperate when both of them get something out of it. Altruism, on the other hand, poses much bigger problems, because natural selection favors selfishness. We've already seen that some species have helpers that forego breeding themselves, which certainly reduces their direct fitness. But this system is taken to extremes in some social insects, for example, bees, wasps, ants, and termites. Many individuals in these species are sterile workers that spend their entire lives helping a queen survive and rear offspring. This social system is referred to as eusociality and is characterized by cooperative care of offspring, individuals dividing into castes, some of which don't reproduce, and mothers and adult offspring being alive at the same time. So why do workers and helpers pay costs and forgo breeding to help others? Why isn't this behavior quickly eliminated by natural selection? The answer is that natural selection really acts on genes, not on individuals. Natural selection favors producing offspring because offspring share the genes of their parents. But any individual you're related to also shares some of your genes in the same way. Let's look at this graphically. We focus on one individual, which possesses a particular set of genes. The individual finds an unrelated mate and produces offspring that share half of its genes. But this individual also has parents, who each provided half of its genes. If its parents produce more offspring, these siblings will also share half the individual's genes on average. If the sibling also finds an unrelated mate and has offspring, those nieces and nephews will each share a quarter of the original individual's genes. You can take this as far as you like. For example, first cousins share 1/8 their genes. This means that individuals can be selected for behavior that benefits relatives in the same way that they're selected for behavior that benefits themselves or their offspring. We use the term inclusive fitness to refer to fitness that an individual gains from all sources, and this is what natural selection maximizes. Inclusive fitness is a combination of the familiar direct fitness gained from your own offspring and indirect fitness gained from helping relatives. So how do animals balance direct and indirect fitness? We can calculate whether we should expect an individual to altruistically help a relative using a simple equation, RB greater than C. This is known as Hamilton's rule. In this equation, B is the fitness benefit to the recipient, C is the fitness cost to the actor, and R is the proportion of genes shared between the two, the relatedness coefficient. For an example, an individual should choose to help its siblings rear 2 extra siblings if it expects to gain less than 2 offspring by breeding directly. As a final note, humans are a good example of a species with plenty of cooperation between both relatives and non-relatives. Take a moment to think about human behavior and sociality. Do you think we're cooperative breeders, according to the definition we used earlier? Likewise, are we eusocial? See you next time.